Hello everyone. This is Dr. R. Sasikumar, Professor, Department of Computer Science and Engineering from RMDEC Engineering College. So today I'm going to discuss about bus arbitration concept in computer architecture. So in that bus arbitration, we have a two keyword. One is a bus master, another one is a bus arbitration technique. So first we know what is called a bus master. The device that initiates a data transfer on the bus. The next device can take control of the bus after the current master surrenders the control. So, which device has full access control, then that device is called what? A bus master. Suppose if the device is complete that work, then it will hand over the signal to the other device. Okay, so how to choose the other device will act as a bus master means what? With the help of a bus arbitration technique. So the bus arbitration, it is a process by which the next device to become master is selected. There are two ways to select the bus master. The first technique is called what? Centralized arbitration. The other one is called what? Distributed arbitration. In that centralized arbitration technique, this is the diagram. We have a DMA controller, one DMA controller, and the processor. BG1 is nothing but what? A bus grad signal. BR bar is nothing but what? A bus request signal. BBSY bar is nothing but what? A bus busy signal. Okay, suppose if more than one DMA controllers are connected with the processor. Suppose if any devices wants to act as a bus master now, then all the devices send the request signal to the processor. So every controller has to send the bus request signal to the processor with the help of BR bar signal. Okay, all the devices can send the BR bar signal, bus request signal to the processor. Then the processor can choose the device based on that priority. Okay, suppose if the DMA controller 1 has the highest priority now, then the bus the processor has to give the bus grant signal to DMA controller 1, right? Before it will send the grant signal to DMA controller, once the processor has choose the DMA controller, then automatically the busy signal will be active. So what is the use of that busy signal means what? The DMA controller one is if the DMA controller 1 is connected to that processor, for example, then the DMA controller 1 generate the busy signal. Okay, what is the purpose of that busy signal means what? It will inform to other device. Currently, I am using the processor, so no need to send any other request signal hereafter. Okay, once the operation is completed, then the DMA controller 1 will release the bus busy signal. Okay, if there is no busy signal means what? Then the other devices are started to send the request signal to the processor. That is the concept of centralized operation. I will repeat once again. So more than one DMA controllers are connected with the processor. According to this example, there are two DMA controllers available. Both are sending the request signal to the processor. The processor can choose the bus DMA controller with the help of a priority. Which one has the highest priority? Then the processor has choose the that DMA controller. After choosing that DMA controller, then the processor issue the grant signal to that particular DMA controller. Once the DMA controller receive the grant signal, then immediately it will generate the busy signal to processor and other devices. What is the purpose of that busy signal means what? It will inform to that nearby controller. Currently, I am using the processor, so no need to send the request signal. After completing that entire operation, then the particular DMA controller which release the busy signal, then automatically the remaining controller keep on sending the request signal to the processor. This is the concept of centralized operation. This is the timing diagram of the centralized operation. Bus request, bus grant signal 1, bus grant signal 2, bus busy signal, bus master. So the initially the bus master is nothing but what? A processor, but certain period of time, any one of the DMA controller will act as a bus master. Then how the DMA controller will act as the bus master means what? It depends upon the request signal. So the bus request signal will be issued by all the DMA controller to the CPU, and the CPU will choose the particular DMA controller based on that priority. Once it is chosen, then it will issue the grant signal to any one of the device, either DMA controller 1 or DMA controller 2. Suppose if the DMA controller 1 is required to access the processor now, then it will receive the grant signal. Otherwise, it will forward that signal to another DMA controller. Once the DMA controller receive the bus grant signal from any one of the processor, then automatically it will issue the bus busy signal. This bus busy signal is nothing but what? It will inform to that nearby DMA controller. Currently, I am using that processor, so no need to send the requested signal hereafter. Once the operation is completed, then the particular DMA controller which release the busy signal from the processor. Okay, then automatically the other DMA controller will send the requested signal. This is the concept of centralized arbitration, and everything will happen based on that priority level. The processor only choose the DMA controller based on the highest priority. So this is no software technique, only based on that hardware only the devices will be selected. So we move on to the other concept. In centralized operation, BR is nothing but what? A bus request. BG is nothing but what? Bus grant. BBSY is nothing but what? A bus busy signal. And the second one is called what? A distributor arbitration. So in that distributor arbitrations, the devices can be selected based on that software, no priority concept. Here purely all the devices can be selected by using software process only. So all devices waiting to use the bus have to carry out the arbitration process, and it has no central arbiter. Each device on the bus is assigned with a 4-bit identification number. One or more devices request the bus by asserting the start arbitration signal and place their identification number on the 4 open collector lines. So this is the diagram. Interface circuit for device A. There are 2 devices are connected. Device A and device B. So which devices will be selected means what? Based on that code, 4-bit identification code. For example, ID of A is 5 and B is 6. Also, the code seen by both devices is 7. So how that each device on the bus is assigned with a 4-bit identification. So orbit 0, 1, 2, 3. There are 4-bit arbitration signal. Then start arbitration. Okay, so once the start arbitration is signal, this is what start arbitration signal. So 0 means what? Here 1 will come because the inverter, and 1 comes means what? Again 0. So this is what interface circuit for device A. Okay, then how to choose that device means what? There are according to this example, there are 2 devices are connected, device A and device B. Right, which devices will be selected means what? ARB0 through to ARB3 are 4 open collector lines. One among the 4 is selected using the code on the line, and one with the highest ID number. Assume that there are 2 devices A and B having ID numbers 5 and 6 respectively, are requesting the use of the bus. Device A transmit the pattern 0101 because the binary number of 5 is what? 0101. The device B transmit the patterns 0110 because the binary number of 6 is 0110. The code seen by both devices 0111. So how to get that code 111 means what? 0111 means what? 0, 1, 0, 1. This is 5. Then 0, 1, 1, 0. This is 6. So number 5, number 6. Okay, now you apply OR gate operation. Apply OR gate operation. 1 plus 0, 1, 0 plus 1, 1, 1 plus 1, 1, 0. This is OR gate operation. So you will get the code seen by the both devices are 0111. So each device compare the pattern on the arbitration line to its own ID, starting from the most significant bit. If it detects the difference at any bit position, it disables its drivers at the bit position and for all the lower order bits. So, for example, the device A is called what? 5. The binary number is what? 0, 1, 0, 1. Okay. The compare device is called what? 0, 111. Okay. So 0, 0, right? Both are same, so no problem. Then it will move on to the next bit. 1, 1. You will get 1. So that is also no problem. And third one, 0 and 1. 0, 1. So for example, 0 Here 0 means what? Here 1. So the next, the whole thing is applied here, and 1 means what? Here 0. So no problem. The next one is what? 1. Here you will get 0, and then 0 means what? 1 you will get. Okay. Then here 0 and 1. 1 means what? This is 1 up to this 1, but you should get 0, but here 1 only. So there is a problem here, right? So if it detects a difference at any, if it detects a difference at any bit position, it disables the driver to all the bits. So hereafter it won't check the remaining bit. So it disables the entire bit. So 5 won't be selected. 5 won't be selected. The next one 6. The 6 is 0, 1, 1, 0. 7, 0, 1, 1, 1. So 0, 0, 0, 1, 1, 1, 1, 1, 1, both are same, right? If it detects at the both the bit position, if both are same thing will appear. So 1, 1, 1 also, 1, 1, 1 also, right? Then 0, 1, different. Different means what? 0 will occur. So 0 will occur, and hereafter no other bit will be selected, but that's all, maximum 4 digit. So what is the final output? 0, 1, 1, 0. So 6 will be selected. So this caused the pattern on the arbitration line to change to 0, 1, 1, 0, which means that B has won the contention. Okay, this is the way to select the device. Okay, I repeat once again, there are 4 arbitration lines, open collector lines are available starting from ARB0 to ARB3. One among the 4 is selected using the code on the line, and one with the highest ID number. For example, assume that there are 2 devices A and B. A is ID number 5 and B is ID number 6. Then the binary number of 5 is 0101 and binary number of 6 is 0110. Then you apply the OR operation. Then you will get one code that is called what? Comparative code. The code seen by both devices is 011. So therefore, each device compare the pattern. This is the pattern. 7 is the pattern. Each device compare the pattern on the arbitration line to its own ID, starting from most significant bit. If it detects a difference at any bit position, then it disable the remaining bits and place the 0. Okay. For example, 010, 011. The first bits are MSB to LSB. First bits are same, no problem. The second bit also same, no problem. But the third bit is different now. Then the remaining bits will be disabled, 0110. So it is not available. So the device 5 will not be selected. Then move on to 6, 0110, 0111, 00 same, 0, 1, 1 same, 1. Here also 1, 1 same, 1, and 0, 1 different. So you put 0, and there are hereafter no bits are required. So 0, 1, 1, 0. So obviously that B has won the contention. This is the way to select the device. So centralized arbitration based on the highest priority, the device will be selected. The distributed arbitration based on the code, the device will be selected. I hope you understand this concept. Thank you.